Our planet is a world of water, a blue marble suspended in the vastness of space, with oceans covering more than two-thirds of its surface. And at the center of this watery world, the Atlantic Ocean beats as its restless heart, pulsing with energy and life. Stretching from the icy poles in the north to the warm embrace of the equator, the Atlantic is more than just a body of water. It's a powerful engine that drives our weather and shapes our climate. It brings gentle rains that nourish the land, but can also unleash ferocious storms that test the resilience of entire coastlines. The Atlantic shapes continents, dictates where we live, and influences every season, from the coldest winters to the hottest summers. Its reach extends far beyond its shores, connecting distant continents and cultures, and serving as a highway for ships, ideas, and even weather systems. Think of the Atlantic as a living, breathing entity, its tides and currents in constant motion, shaping coastlines and carrying life across vast distances. The ocean stores and moves vast amounts of heat, redistributing energy around the globe and balancing temperatures between continents. This movement creates everything from light breezes that cool summer days to destructive hurricanes that can change lives in an instant. The Atlantic connects events in Florida to weather in London, linking cities and people thousands of miles apart through invisible threads of air and water. And droughts in Africa can be traced to changes far out at sea, as the ocean's moods ripple across continents. Understanding this ocean is essential for our survival, the safety of our cities, and the future of generations to come. In this journey, we'll follow hidden rivers of water beneath the surface, tracing their paths as they shape weather and climate. We'll witness the birth of storms, from their first swirling clouds to their powerful landfalls, and see how the dance between warmth and cold shapes entire regions, influencing everything from ocean life to human history. The Atlantic is a dynamic, unpredictable force at the core of Earth's climate, always changing, always surprising. By understanding its rhythms, we better appreciate the intricate web of life it supports, and our own place within it. The story of our weather is, in many ways, the story of the Atlantic, a tale of connection, power, and transformation. Let's dive in and discover how this mighty ocean shapes our world, from the smallest raindrop to the mightiest storm. Its influence is everywhere, touching our lives in ways we often don't realize, even if we can't always see it. The Atlantic story is one of connection, power, and constant change, a story written in water, wind, and time. And it's a story that affects us all, no matter where we live or how far we are from its shores. Beneath the Atlantic's surface, powerful rivers of water, ocean currents, flow endlessly, shaping the very foundation of our planet's climate and ecosystems. These currents are driven by a combination of forces: the persistent push of wind, the spinning of the earth, and subtle differences in temperature and saltiness, or salinity, across vast distances. Warm, less salty water tends to stay near the surface, while colder, saltier water sinks below, creating a global conveyor belt that circulates energy and nutrients around the world. This immense system, known as the Atlantic Meridional Overturning Circulation, or AMOC, moves vast amounts of heat from the tropics northward, acting as a giant engine for our climate. As warm water travels north, it releases heat into the atmosphere, making Europe's climate much milder than its latitude would otherwise allow, and supporting millions of lives. Near Greenland, the water cools dramatically, becomes denser, and sinks, beginning a slow, deep journey southward through the Atlantic's depths. This conveyor belt is the heart of the Atlantic's climate engine, moving more water than all the world's rivers combined, and circulating life-sustaining elements across continents. Without this circulation, the tropics would scorch under relentless heat, while the north would freeze, making much of the world uninhabitable. The Atlantic's currents are our planet's central heating and cooling system, balancing temperatures and supporting weather patterns everywhere. They form a complex network: gyres, eddies, and swirling flows, all mixing heat, salt, and nutrients, and supporting a rich diversity of marine life. This intricate dance of water shapes life on Earth, influences our daily weather, and even affects the air we breathe. Understanding these hidden rivers is key to understanding our climate, predicting future changes, and protecting our planet. The ocean's constant motion is a web of cause and effect, millions of years in the making, connecting past, present, and future. Every current, every swirl plays a vital role in maintaining the planet's delicate balance and supporting life as we know it. The Atlantic's currents are the lifeblood of our climate, pulsing with energy and movement. Their movement connects continents, shapes our world, and enables trade, migration, and the spread of life. To understand the Atlantic is to understand the powerful forces that shape our lives, our weather, and our future. The story of these currents is the story of our weather, our climate, and ultimately, our shared existence on Earth. The Gulf Stream is the Atlantic's most famous current, a warm, swift river of water flowing from the Gulf of Mexico, winding up the U.S. coast, and then stretching all the way across the ocean to Europe. It's a powerful force, moving more water than all the world's rivers combined. From space, its deep blue warmth stands out in sharp contrast against the cooler, darker waters of the Atlantic, creating a visible ribbon of heat that snakes across the ocean. The Gulf Stream transports immense amounts of tropical heat northward, shaping weather patterns all along North America's east coast and far beyond. It keeps the southeast U.S. warm and humid, especially in winter, making the region lush and green when other places are cold and barren. Where warm ocean air meets cold continental air, powerful storms form, like nor'easters and heavy coastal rains that can reshape entire shorelines. As the Gulf Stream crosses the Atlantic, it becomes the North Atlantic Current, carrying its warmth all the way to the shores of Europe. This is why London's winters are mild and damp compared to cities at similar latitudes, like Calgary, which endures harsh, snowy winters. The current keeps Norwegian ports ice-free, even within the Arctic Circle, allowing ships to travel and trade year-round. The Gulf Stream makes land fertile and habitable, supporting rich marine life and thriving coastal communities. But it's sensitive. Climate change and melting Greenland ice could slow its flow, with dramatic consequences for weather, sea levels, and life on both sides of the Atlantic. The Gulf Stream is a lifeline, but also a reminder of our planet's delicate balance and the interconnectedness of our climate systems. Its warmth shapes continents and cultures, influencing everything from agriculture to architecture. Scientists watch it closely, knowing its fate affects us all, and that changes in its flow could ripple across the globe. The Gulf Stream's journey is a story of connection and vulnerability, a river of warmth that links continents, climates, and people. The warm tropical Atlantic is the birthplace of hurricanes, Earth's most powerful storms. Hurricanes form when ocean temperatures reach at least 26.5 degrees, 80 degrees, to a depth of 50 meters. Warm water fuels rising moist air, which condenses into clouds, releasing heat and driving the storm's growth. If wind conditions are right, the system intensifies, spinning into a hurricane with a calm eye at its center. The Atlantic not only creates these storms, but also steers them, guiding some out to sea and others toward land. Hurricane Katrina, for example, formed over warm Atlantic waters before devastating New Orleans. The Atlantic's warmth is the source of their power and their threat. Understanding hurricane formation helps us prepare for nature's fiercest storms. The Atlantic doesn't just fuel storms, it can trigger intense heat waves on land. Marine heat waves occur when large ocean areas become unusually warm for weeks or months. These events can shift the Azores High, a key pressure system, creating a heat dome over Europe. Under this dome, air sinks and heats up, blocking clouds and rain, leading to relentless heat. The 2003 European heat wave, one of the deadliest, was linked to such patterns. The ocean and atmosphere are in constant conversation. A warmer Atlantic can mean hotter, drier summers. Heat waves strain power grids, threaten health, and devastate agriculture. The memory of ocean heat can haunt us on land long after the water warms. The Atlantic's hidden warmth shapes our summers in ways we're only beginning to understand. Watching the ocean is key to predicting and surviving future heat waves. The Atlantic creates strikingly different climates on its opposite shores. New York and Porto, Portugal, share a latitude but have contrasting weather. New York's winters are harsh, Porto's are mild. Prevailing winds and ocean currents are the reason. In North America, winds blow from land to sea, bringing cold air in winter. In Europe, winds blow from sea to land, carrying warmth from the North Atlantic Current. The cold Labrador Current meets the Gulf Stream off North America, creating sharp contrasts and fog. Europe's coast is bathed in warmth, acting like a giant hot water bottle. The Atlantic's circulation redistributes heat, shaping cultures and ecosystems on both sides. A continent's climate is more than latitude, it's about its relationship with the ocean. The Atlantic's influence is the difference between bitter cold and gentle rain. The Atlantic's reach extends far beyond its shores, shaping weather across the globe. Its warming and cooling patterns influence rainfall in the Amazon and the Sahel in Africa. When the North Atlantic warms, rain bands shift, causing droughts in the Amazon and changing monsoons in Africa. Millions depend on these distant ocean patterns for their livelihoods. These teleconnections show the Atlantic is a central cog in the global climate machine. Its heat shifts jet streams, affects El Niño, and even influences the Indian monsoon. The Atlantic is in constant dialogue with other oceans and the atmosphere. Our climate is a single, interconnected system, shaped by the Atlantic's pulse. The Atlantic's power to shape weather and climate means we must watch it closely. Accurate forecasts depend on understanding ocean-atmosphere interactions. Monitoring the Atlantic helps predict hurricanes, rising seas, and shifting rainfall. Scientists use satellites, robotic floats, and research ships to track its health. This data guides decisions on coastal defenses, farming, and disaster preparation. Changes in the Atlantic affect fish, coral reefs, and entire ecosystems. The ocean regulates temperature, drives the water cycle, and absorbs carbon dioxide. Investing in ocean science is investing in our future. The more we understand the Atlantic, the better we can protect life on Earth. The Atlantic is a living, dynamic force, its pulse felt across the globe. Its currents deliver warmth, unleash storms, and regulate our climate. We've seen how its hidden rivers shape continents and connect distant lands. Our dependence on the Atlantic is profound, but so is our vulnerability. As the ocean changes, so does our future. Understanding its rhythms is one of our greatest scientific challenges. The Atlantic story is now intertwined with our own. To respect its power is essential for the well-being of our civilization and the planet.